All right, we're in section 4.4 of Al Grosch's book, Developmental Math 2, and this is going to be an introduction to polynomials. First off is the question, what is a polynomial? A polynomial is defined, and it's really kind of interesting because the definition is not even here. A polynomial is defined as the sum of terms. So there are no equal signs in polynomials, although polynomials can be joined together with an equal sign to make an equation. Polynomials are terms, any number of terms from 1 to an infinite amount. Of course, we're not going to use an infinite amount of terms in this lesson. The terms of a polynomial, and some of those definitions are down here. The terms of a polynomial are separated by the plus and minus signs. Inside of a term, there can be numbers, variables, exponents. The degree of the term is the sum of the exponents. We're going to talk about degree in just a minute. The coefficient of a term is the number part at the front of the term. We see some definitions for different types of polynomials here. A monomial has one term, and here there are 4 examples of monomials. These are all polynomials that just have one term. Notice there are more than one factor. There can be more than one factor in a monomial, but the terms are separated by plus and minus signs. So you can see there are no plus and minus signs. This is 4 different monomials, which means one term. A polynomial with 2 terms is called a binomial, and here you can see a few examples of binomials. And now, since there's more than one term, we can see the terms being separated by plus and minus signs. Here, there's a plus sign which separates 2 terms. Here, a minus sign separates 2 terms, the plus sign, 2 terms, and here, 2 terms. A trinomial is a polynomial that has 3 terms, and here we have 3 trinomials. And again, the plus and minus signs separate the terms, so you can see there are 3 terms in each of these trinomials. A polynomial is a mathematical expression written as the sum of terms. So these are all examples of polynomials. This is a monomial, 1 term, a binomial with 2 terms, a trinomial has 3 terms, and this polynomial has 4 terms because they're separated by the plus and minus signs. So this polynomial is what we call a polynomial with 4 terms, or a 4-term polynomial. So down here toward the bottom, we're just going to practice classifying using that vocabulary we just learned. Monomial, binomial, or trinomial. In this first example, I like to just draw a vertical line where every place I see the plus and minus signs, and that tells me there are 3 terms. So this is a trinomial. In the second example, this tells me there are only 2 terms. So this is a binomial. In the third example, there are no plus and minus signs. This is all 1 term. Yes, there are a lot of factors in this term, but the terms are separated by plus and minus signs. So this is all 1 term. So we call this a monomial. In the last example here, it looks like there are 2 terms. However, both these terms have an x cubed. These are what we call like terms. We've talked about like terms in an earlier lesson. And since they are like terms, we need to combine like terms before we can classify this polynomial. So 6x cubed minus 5x cubed leaves 1x cubed, because combining like terms, we just add the coefficients, the 6 and the negative 5. That leaves 1x cubed, which tells us there's only 1 term. So this is also a monomial. All right, we're going to continue on with some examples here of polynomials. The first example says, given this polynomial, list the terms. All right, so I'm just going to zoom a little bit here. We're going to use the plus separation with the plus and minus signs. So there are 4 terms here. So we call this a polynomial with 4 terms. To list the terms, we're just going to first identify the first term is 4x to the 7. The second term is negative 2x to the 4th y squared. That negative goes with the 2. The third term is negative 6x squared y. And the last term is 3y cubed. So 4 terms. This next question says list the coefficient of each term. The coefficient is the number at the front of the term. So each term has a coefficient. The coefficients are 4, negative 2, negative 6, and 3, all from just the beginning of each term. Find the degree of each term. Okay, we haven't talked about degree yet, but the degree is found by adding, so it's the sum of the exponents on the variables in each term. So the degree of the first term would just be the sum of the exponents, and that would be a 7. The degree of the second term, I'm going to write here, would be the sum of this exponent, so 4 plus 2 is 6. The degree of the third term, we have a 2 here, and don't forget this y, since it has no exponent, it has the invisible 1 on it, so that degree is 3. And the degree of the last term would just be the 3 here. So those are the degrees of the terms. To find the degree of the polynomial, we just take the highest of the degrees. So this is just the highest of the degrees of the terms. So we look at these and we just choose the highest one. So we have a 7, a 6, a 3, and a 3, and so the highest one would be 7. So the degree of this polynomial is 7. We're actually not going to use degree for anything in this course, but you will use it in a higher level algebra course. All right, down here we have, on example 2, a new polynomial. Here, we're going to list the terms, and I'm going to use the vertical lines where the plus and minus are to show me there are 4 terms. Again, so to list the terms, we will have AB, 6a cubed, b squared, negative 4, ab to the 7, and 8. Those are the 4 terms of this polynomial. So now we're going to list the coefficients of each term. And don't forget, the coefficient is the number at the beginning of each term. Well, here in the first term, there is no number, so don't forget when there isn't a coefficient, it's implied to be the invisible 1. So we have a coefficient of 1, 6, negative 4, and 8. To find the degree of each term, we add the exponents on the variables. So these variables have the invisible 1 exponent. When we add them, 1 plus 1, we get 2. In the second term, we add the exponents to get 5. In the third term, we've got another invisible 1 and a 7, so that makes it 8. And in the last term, there are no variables. So the degree is 0 because there are no variables with exponents. All right, to find the degree of the polynomial, we just choose the highest of the degree terms. And of course, that will be the 8. All right, on this page, we're going to evaluate a polynomial. Now, if you've been watching the videos all along for this series, we did some evaluate in chapter 1, I believe, at the end of chapter 1. And this is the same thing. So this is kind of a repeat. But if you didn't watch that video, then now's the time to catch it. To evaluate a polynomial, here we have a trinomial, and we're given the value of x as negative 1. We're going to replace the x with a negative 1, then we're just going to use order of operations to simplify. So your parentheses are your best friend here, and the way I usually do this is just by starting to write the expression. I have a negative 2, and then instead of x, I'm going to use a parentheses, and the square will go outside of it. So every place I have a variable, I will put parentheses, and then I will place inside these parentheses the value for that variable, which is negative 1. That helps you with your negatives, your exponents, and your multiplication if you use the parentheses. Now we just simplify. Using order of operations, we work inside grouping symbols first, But these grouping symbols don't have any operations inside them, so we're okay with that. The next step for order of operations is exponents. So we do have an exponent here. Negative 1 squared is negative 1 times negative 1, which makes positive 1. And then we just carry down everything we haven't used. The next step in order of operations is multiply and divide left to right. So we only have the one multiply right here. 2 times positive 1 is negative 2. And then when we get done with that multiply, we do the add / subtract, where we can identify this is a negative, this is a negative, and this is negative. These are all negatives, so they're all on the same team, so they're going to clump up and join together. So negative 2 plus negative 1 plus negative 5 makes negative 8. So that's all there is to evaluate. Just replace any variables you have with the value, their own value, and then use order of operations to simplify. So I think we've got another one down here below. All right, we're going to evaluate this polynomial when x equals negative 2. So again, I'm going to start off by writing the expression, leaving out the variables, replacing them with parentheses, and then inside the parentheses, the value for the variable. And now I just proceed with order of operations. So grouping symbols first. This time we do have grouping symbols. I have an operation inside them. That's negative 2 minus 5 makes negative 7. We still have that square out there. You want to be careful here when you have these two negatives, because a lot of students will automatically cancel these and make them positive, and that will be fine, except that we have an exponent here. When you're canceling negatives like this, that's a multiplication operation. Don't do it before you do the exponent. You have to do exponents after grouping symbols and before multiply and divide. So we need to do this exponent first before we cancel these negative signs. So this is saying, actually we've got an exponent here and an exponent here. So let's do left to right. Negative 7 squared is negative 7 times negative 7, which makes positive 49. Negative 2 squared is negative 2 times negative 2, which makes positive 4. And this negative sign is still there. So you see what would have happened if I did this out of order and canceled these. I would have ended up with a positive sign here, which would have made this an entirely different answer. So exponents are now done. There is no multiply and divide, so we're down to the add, which in this case is positive 49 minus positive 4. So 49 minus 4 makes 45. All right, here we just have a little bit of an introduction to graphing non-linear equations. In chapter 3 of this book, we graphed linear equations, and linear equations are equations that make a straight line when we graph them. These are nonlinear equations, which means that they are not going to be straight lines. They're going to start to have curves in them. And if you look carefully at this equation that we're being given to graph, the reason that is nonlinear is because of this exponent in here now. When we start putting exponents on our variables, our graphs start turning into curves. So we're going to graph a little bit of a curve here using a table, and this is the only method we're going to use for right now. In a higher level course, we'll learn some other methods. But to do this, we're just going to choose some values of x, evaluate to find out the corresponding value of y, and this is going to give us ordered pairs, which we can then put on our graph, which is over there now. It's off my page. So let's just choose some convenient values for x. I always like to use 0. In this case, I'm going to use 1, negative 1, 2, and negative 2. And let's see. I'm just going to put this over here so I have some space over here to do the math of evaluate. We're going to substitute 0 for x, and that's going to give us y equals 0 squared minus 3. Well, 0 squared is just 0. So y equals negative 3 here. And then we'll do the same thing with x equals 1. We'll put a 1 in here. So we'll have y equals 1 squared minus 3. Well, 1 squared is 1. 1 minus 3 makes negative 2. I'm trying to conserve space, so I'm not putting all of the work here because I want to be able to do all of these here. You can, wherever you have space. So I'm going to substitute in a negative 1 for x. Being careful, of course, with that exponent. The negative 1 is the x, it's in parentheses, the exponent is on the outside. So negative 1 squared, negative 1 times negative 1 is positive 1. Positive 1 minus 3 still makes negative 2. Then I'm going to substitute in positive 2. So y equals 2 squared minus 3, or 4 minus 3, which is 1. And y equals negative 2. So negative 2 squared minus 3, which is 4 minus 3, which is 1. And now we have 5 ordered pairs that we can put on our graph. I'm going to have to probably reduce this so that I can see it all at the same time. Okay, so this will be interesting to try and do, right? The first ordered pair is 0, negative 3. All right, I don't want to make you guys nauseous by doing this, but I can't graph this without enlarging it. The first ordered pair is 0, negative 3, which would be here on the y-axis. The next ordered pair is 1, negative 2. So 1, negative 2 will be right here. The next ordered pair is negative 1, negative 2. Negative 1, negative 2. We'll put a point here. We can already see that it's not a straight line. And it isn't going to be a straight line because of that square in there. The next ordered pair is 2, 1. So 2, 1 will be up here. And the third one was negative 2, 1. So negative 2, 1. All right. If I connect these dots, points, the best I can, I get a curve that looks like this. And this is called a parabola. And this is what any equation that has a squared term in it comes out to look like a U. We call them a parabola. Parabola. It can be an upward facing U like mine is, or it can also come out to be downward facing. And there are certain elements in the actual equation that control whether it's upward, opening upward, or downward. All right, down here we have a new equation. This time we don't have a square in the equation, we have a cube. So this is going to still make some kind of a curved graph, but it isn't going to be a parabola this time. We'll have to see what it looks like. Okay, so we got to choose some values for x, so we can substitute it in here. I'm going to go with the same ones. 0, 1, negative 1, 2, negative 2. They're convenient values to work with. And then we're going to substitute those values in here for x and evaluate to find the corresponding values of y, which will make ordered pairs. So if x is 0, y will be 0 cubed plus 2. Well, 0 cubed is just 0, plus 2 is 2. When x is 1, we'll substitute that in there. Y equals 1 cubed plus 2. Well, 1 cubed is 1. 1 plus 2 is 3. Okay? When x is negative 1, we'll put the negative 1 in there. Y will equal negative 1 cubed plus 2. Negative 1 cubed is negative 1 times negative 1 times negative 1, which makes negative 1 plus 2, and that comes out to be a positive 1. When x is 2, we'll put a 2 in here. Y will be 2 cubed plus 2. 2 cubed is 8. 2 times 2 times 2. And 8 plus 2 is 10. Okay, lastly, when x is negative 2, we'll put a negative 2 in there. Y equals negative 2 cubed plus 2. Negative 2 cubed is negative 2 times negative 2 times negative 2. Comes out to be negative 8 plus 2. Makes negative 6. And we have our ordered pairs here. Just by evaluating into the given function equation and simplifying. Of course, always being careful with the signs. When we evaluate a variable that has an exponent on it, use the parentheses. The whole entire value of the variable goes in the parentheses. So when the variable was negative, this cube goes on the outside of the parentheses. Okay, so again, I don't want to make you guys nauseous, but the only way for me to graph these is to enlarge and reduce. The first ordered pair is 0, 2. So 0, 2 is here. The second ordered pair is 1, 3. So 1, 3 is here. Oh, I didn't get it right on there. Okay. The third ordered pair is negative 1, 1. So negative 1, 1. It looks like a straight line. Is it? Two, 10. So 2, 10 should be right up here. And negative 2, negative 6. Let's see. Negative 2, 6. Be right here. So it's not a straight line. In fact, it looks like this. And this is what cube equations come out to look like. I call it a sneaky thing. I don't know. I don't think it has an official name, but that's what cubed functions come out to look like.